Good afternoon. Welcome, and thank you for joining us today. Businesses are creating increasingly more data, using it for more purposes, and needing to keep it for longer. At the same time, the cost of storage is rising, and businesses are looking to use the cloud to help control these costs. My name is Paul Reed. I'm a product manager for AWS Storage Gateway, a service that simplifies adoption of cost-effective, secure, and scalable storage in AWS. In this session, we'll take a look at how Storage Gateway works. We'll set up a gateway, as long as the demo gods are on my side today. And we'll look at how to monitor and manage that gateway. I'll cover some tips and tricks as we go to help you understand how to use the service and how to get the most out of using it. Storage Gateway expands or replaces your on-premises storage using a software appliance that connects to AWS storage services. Storage Gateway works with your existing applications using industry-standard storage protocols. You don't need to modify your applications or use new data management tools. In Windows, Storage Gateway appears as a new drive letter rather. In Linux, it can be mounted as a file system. Applications are unaware that they're reading and writing data to and from the cloud. Data is encrypted before it leaves your data center and while it's stored in AWS. Data storage is durably backed by Amazon S3, Glacier, and EBS. The data you access most frequently is kept on premises, giving low latency access to this data, which is stored durably in AWS. Like many AWS services, you only pay for the storage you use, and there's no need to over-provision. Excuse me. You can expand or reduce your storage without needing to add or remove hardware. Customers love this kind of elasticity and agility. We see customers adopting Storage Gateway for 4 use cases. The first is backup and archive, which is a natural fit for cost-effective cloud storage. Many customers start here, where Storage Gateway can be added to your existing backup processes without impacting production operations. The second common use case is disaster recovery. Customers use the service for secure and durable offsite storage in the event of a disaster. Using Storage Gateway allows for data recovery to a secondary data center or into AWS, which is increasingly becoming the disaster recovery site for many customers. The next use case is customers who are migrating or need to mirror data sets into AWS. Storage Gateway simplifies the process, moving your data asynchronously while it's still online. Lastly, we see customers wanting to replace or expand their on-premises storage. Perhaps to reduce cost, increase durability, improve security, or just get out of the business of running your own data center. Storage Gateway provides a flexible and agile way to address these storage needs. Let's take a look at how the service works. On premises, your application server connects to AWS Storage Gateway appliance. Your application could be a backup server, a Windows or Linux file server, a SAN or a NAS device that needs expanding, or any other application that just wants access to cloud storage. The application, or the appliance rather, connects to the Storage Gateway backend securely over the internet or using AWS Direct Connect. We use HTTP port 443, HTTPS, so it's a firewall-friendly reverse connection out of your data center. The backend, in turn, integrates with Amazon S3, Glacier, and EBS. We'll talk why we use 3 different services when we look at the individual configurations in a moment. So how does your application write data up to AWS? Firstly, the appliance, presents storage to your application over the iSCSI block storage protocol. When the application writes blocks of data to the gateway stores it locally, takes just the change pieces, and sends them securely up to the AWS Storage Gateway backend. The backend, in turn, takes these small, compressed pieces of data and stores them durably in S3, EBS, or Glacier. When you go to read data, the process works in reverse. Your application server reaches out to the appliance, again over iSCSI, requests a block of data. If that data is stored locally, the appliance returns it to your application. If the data is not stored locally, the appliance reaches out to the service backend to request the data. The backend fetches it from the underlying storage services, returns it up to the gateway. The gateway decompresses the data, stores it locally, and returns it to your application. Your application interacts with the block storage devices as if it was part of the gateway itself, part of the appliance itself, and it's unaware of where the data is stored. The gateway manages both the data stored locally and the data stored in AWS to ensure the storage remains consistent and the data is durably stored. Taking these basic concepts, there are 3 different gateway configurations: gateway stored volumes, gateway cached volumes, and a gateway virtual tape library. Stored and cached volumes provide iSCSI block storage, and the VTL provides iSCSI virtual tape storage. Let's look at each of these in a little more detail. Gateway stored volumes are ideal for disaster recovery or offsite backups of your existing storage. Applications such as databases or computational workloads where low latency is critical and the working set of data is large, ill-defined, or constantly changing. All your data is stored on premises on your local storage, and the gateway asynchronously backs this data up to AWS. You can create point-in-time backups, which are made available as EBS snapshots. On a stored volume gateway, you can configure up to 12 volumes, up to 16 terabytes each, for a total of 192 terabytes per gateway. Gateway cached volumes are ideal for expanding your available storage without needing to buy and deploy additional hardware. Applications such as backup or file sharing, where you have a small amount of data that you need low latency access to relative to the total amount of storage you have. All your data is stored in AWS, with the frequently accessed data cached on the gateway. As with stored volumes, you can create point-in-time backups, which are made available to you as EBS snaps. On a cached volume gateway, you can configure up to 32 volumes, up to 32 terabytes each, for a total of 1 petabyte of storage per gateway. Gateway VTL, virtual tape library, is ideal for replacing on-premises physical tape infrastructure for backup and archive uses. Similar to cached volumes, all of your data is durably stored in AWS, with your frequently accessed data cached on the gateway. In your VTL, you can configure up to 1,500 tapes, up to 2.5 terabytes each, size of an LTO6 tape, for a total of 150 terabytes per VTL. For longer-term storage, you can archive your tapes to a virtual tape shelf. Now, this is backed by Glacier, so it provides a cost-effective long-term storage, and there's no limits on the number of tapes that you can move to VTS. Gateway VTL is supported by backup applications from Symantec, Dell, Microsoft, and Veeam, and we're actively working on adding more to that list. So now the demo part. So let's deploy a gateway and just show how easy it is to onboard with the service. So imagine I'm an IT administrator. It's late on a Friday night, near the end of the quarter. My pager goes off. The main file server is 90% full. Now I know that my quarterly backup job's going to run tonight, and it's going to fill that file server. So I need more storage quickly, or it's going to be a really long weekend. So a similar problem happened at one of our customers recently. It being the end of the quarter, and they solved it with a gateway cached volume in less than 5 minutes. So our first stop's to the AWS Console. First stop's the AWS Console. Now we're going to activate in Oregon. The service is available in all of our public regions today. We'll choose Oregon. It's close. You'll notice I have a couple of shortcuts up here. This is something that I like on the console just to give me quick access to services that I use a lot. Gateway's down here. So we can go to the Storage Gateway console. And you see I already have I was already practicing earlier. So let's deploy a new gateway. In this instance, we're going to deploy a cached volume gateway. So I'll click through the wizard. It's warning me that I need to host this somewhere. So I'm going to host it on VMware. We also support Hyper-V, and we have an EC2 image as well if you'd like to host inside EC2. At this point, I would normally download the VM image, but I already have it locally just to save the time on doing that, so I'll skip that step. We have a very rich set of documentation that gives you step-by-step instructions on how to activate a gateway. We include some of that here in sort of a short form within the wizard to just help you get going and save you having to click out to the documentation. Whoops. So now, at this point in the activation, it's asking me for the IP address of my gateway. So we'll flip over to VMware. I'm hosting it local here on VMware Player. We'll start up the VM that I imported earlier. So I mentioned that the gateway does outbound connections, which is really important. So the IP address that the activation process is asking me for is the local IP address on the LAN. There's no requirement for a public IP address for the gateway itself. It sits on your network securely. Hopefully it comes up, assuming this network is going to behave. If not, I do have a video that we can switch to. Normally the network setup's the one that hangs, so hopefully we're in good shape here. So now we hit the local console. I'm going to sign into the local console and just give you a view for what the kind of things you can do in there. Yep, there's a default user ID and password that you can change. So here in the local console, you can set up networking. The default settings are for DHCP. If you sit behind a SOC server, you can configure that. And there's a couple of other things. But really, the local console is about getting your gateway connected into the back-end service. Since we're going to activate in Oregon, let's just check to see that we have connectivity to that region. So we'll take option 3, network connectivity test. Region 3 is Oregon. So what the gateway will now do is it'll make sure that it can connect outbound to the service endpoints that it needs in order to communicate to the service securely. And hopefully these pass. Great. So we're connected into Oregon. So let's find the IP address of this gateway so that we can activate it. We'll go into option 2, network configuration. We'll describe the network adapter. We only have one on this particular VM. And hopefully everybody can remember the IP address here. It's the 10 address, 10.45.0.53. Again, that's a non-routable address. It's local to my laptop here, the local switch that VMware is providing for me. Hopefully that's the right address. And this is the bit that has been having problems this week for some reason. The network here is quite active. So what's happening now is that, or what happened there, is that the back end of the service and the VM appliance and my browser are doing a little dance to ensure that the VM gets associated with my account that I signed into on the console and gets a secure key that only this gateway has to talk to the back-end service. So this gateway gets sort of tied to your account, and we use those keys for the SSL negotiation, for sending data up to the back end when we get going. We're in the Pacific, and we'll call it demo. Hopefully this will also, feeling lucky I got this far. Drum roll. Oop. So we're redirected back to the console, and you'll see we have a new gateway on the left-hand side here, which is the gateway that I just set up. In this instance, it has no volumes defined, so let's create a storage volume. Oops, I have no disks available. Okay. Oh, that's right. We need to assign a cache volume and an upload buffer. So let's go back to our VMware instance. Go into VM settings. You see we only have one disk, which is our root volume. We need an upload buffer and a cache. We're creating a cached gateway. So we'll add hardware. Of course, it needs admin privileges. So we'll add a hard drive to this VM. It really doesn't matter what type it is. For the purpose of this, I'm just going to use small drives. 20 gigabytes is fine. For your use case, you may want to, and we'll talk about it as we go back to the slides, how big to size your disks based on your specific workload. I need an upload buffer, and I need a cache. So let's create a second drive. We typically recommend creating the cache slightly larger by about 10% or more than your upload buffer initially. Again, these can be changed later on. We'll talk about how to monitor the gateway to understand whether your configuration is correct. So now I go back here. My VM will magically restore, and the drives will get added to the VM. Switch back to the AWS console. Hopefully it will work this time. Ta-da! So we'll allocate the smaller drive as our upload buffer, the larger drive as our cache. The next thing it asks me to do is to set up some alarms. We integrate with CloudWatch, and we'll talk about this. So I'll skip this step for now, but this is sort of really trying to get people to use CloudWatch and use that to monitor the service so it doesn't become a black box. And we'll look at some of the CloudWatch metrics that we provide and how you can use them when we flip back to the PowerPoint. So we're trying to create a volume. Let's create a 1 terabyte volume here. We support CHAP authentication on the iSCSI connection. Again, for the purposes of the demo, I'll skip that. You'll see we now have a 1 terabyte volume defined on the gateway. So if I go back to my local client and try and connect to that volume, we'll use the iSCSI initiator in Windows here. I need that IP address, which I'm hoping I can remember. 43? 45? I'm glad there's people down there watching. Let's see if you're right. So we've connected, and we look at the targets available on that device, and we have that volume that we just created. Let's connect to that volume. Connected. Let's open the Windows Disk Manager. And if this is behaving, it should recognize that there's a new drive that hasn't been initialized. Drum roll. I can close out that. I don't need it anymore. This is the bit I didn't think would not work out. There you go. It recognizes that there's a new drive. Initializes it. Here's our drive. A terabyte of data. We can then go and format it, just as you would any other Windows drive or new Windows device. Windows will then go away and format it. What's happening here is Windows is just treating this as a normal block device. The gateway that's running is handling the blocks that are being changed as we format the drive, sending the changes up to AWS for durable storage. It's a cached volume after all, and maintaining them locally in the cache at the same time. So the drive's being formatted. As we see, Windows is recognized as a new drive. Here it is, menu volume. And I can obviously create files as I would any other drive. Hi. Save them out. Windows is unaware that really what's happening under the covers is this whole device is being actually stored in AWS. If I go back to the console, here's my drive. I can create a snapshot from that. Here I have some snapshots. Let's take this snapshot ID. An arbitrary snapshot. And I'm going to go back to my gateway. And I'm going to create a new volume. In this instance, instead of creating a volume from scratch, I'm going to create it from that snapshot. think it's a 1 terabyte. Oh, I can't call it the same thing. Again, it's going to ask me if I want to do CHAP authentication. I'm going to be a little naughty and not do it. So I have another volume. If I go back to, I probably have to go back to my iSCSI initiator. Refresh my list. And I see the new volume that I just created. Again, I can connect to that volume. Connected. If I go into my Windows, actually I could get rid of that. If I go back into Windows Drive Manager, you'll see I have a new volume. In this case, it was restored from a snapshot, so there was no need to format it, although I'm noting that it's offline. I've created too many drives on this demo. Normally, that volume would just appear and it would already be populated with data, but let me see if I can fix this by disconnecting the original volume. Anyway, I won't belabor the point. You get the idea. I can create volumes from either a scratch volume, a new one. Windows sees no difference. It can read and write to it, and I can create volumes from a snapshot of the volume and bring them back to the same host or a different host. You can also switch between volume types. So I could take a snapshot from a cached volume and restore it as a stored volume, or I could take a snapshot from a stored volume, restore it as a cached volume, or I could take a snapshot from an EBS volume and bring it to my gateway. So snapshots are interchangeable between all three formats, if you like, EBS, stored, and cached. So now that we have a gateway, and you've seen how easy it is to get up and running and create cloud-backed storage, let's look at how you can monitor and manage your gateway. So one of the first things you might want to do is a system resource check, and you may have noticed this on the local console menu. This ensures that you've given enough virtual resources in your hypervisor to the VM. If you don't give the gateway sufficient resources, it will actually fail to start. So this is a super important thing to check. System resource checks available in the local console and the VM, as I mentioned. And here we see a gateway that's showing a warning. If we go into that option, we'll see that we've given the VM less than the recommended amount of memory. In this case, the VM will still start because we're just less than the recommended, we're not less than the minimum. In the next example, we'll see a more severe case where the gateway will refuse to start. It has both an error and a warning. When we look at the details here, we'll see we've provisioned a rather undersized VM. So worth checking that before you start using your gateway, because that may be the cause of some of the performance or other problems you may be having. One of the first things that a lot of customers ask is, how do I know what's going on with my gateway? Or how should I tune my gateway for better performance? CloudWatch lets you monitor your gateway to understand what's going on. And CloudWatch alarms provide a great way to be notified of unusual events. So you can proactively adjust your configuration before problems occur. Let's take a look at some of the CloudWatch metrics that Gateway provides and how you can use them to optimize throughput. So there's two aspects to write performance: the performance of your application writing to the gateway, and the performance of your gateway uploading data to AWS. The local storage that you assign to the gateway stores data temporarily to accommodate the difference between these. CloudWatch lets you understand if your local storage is sufficient for your application workload, and as your application writes data, the changes are written to the cache and the upload buffer. So you'll want to watch both cache % dirty and the upload buffer % used to monitor this. It's really important not to fill your upload buffer, since the gateway needs this to temporarily store and queue data that it's uploading. The gateway will actually begin to throttle writes if there's a risk of running out of temporary storage in order to give it some time to upload data. And so setting alarms before this happens is a good thing because it saves throttling your application, being able to write data. CloudWatch can also help you understand how your application works. So for example, some applications repeatedly overwrite the same part of a given volume. You'll see this as growth in the upload buffer, which tracks all changes, without corresponding growth in your cache, which just keeps the latest piece of data. In this case, increasing the size of your upload buffer may prove to be more beneficial to your throughput than increasing the size of your cache, because you can avoid getting hit by that throttle once your upload buffer hits the sort of 70, 80, 90% full. It's worth pointing out that we do try to collapse overwrites in the upload buffer, as long as they're made within a specific window. This avoids uploading data which you've subsequently overwritten, so it's unnecessary. And it ensures that the most recent data is durably stored in AWS as quickly as possible. It also helps reduce the need to expand your upload buffer. Now, we've recently added a new metric called time since last recovery point. This indicates how old the last recovery point is for your volume. Recovery points are a crash-consistent copy of your volume that we make available to you in case of a catastrophic failure locally. And it's a good metric because it helps inform you of what your recovery point objective you're achieving is. It tells you how much data you're going to lose if your gateway was to go on fire. Monitoring read performance is primarily about monitoring the cache. For low latency access, you want to be reading data that's in the cache. Sounds obvious. So you'd see a high cache hit percent. Your cache hit rate will drop, and hence latency will increase if your cache fills. And the data needs to be downloaded from AWS to satisfy read requests. A full cache may be an indication that your working set is either larger than you anticipated, or that your workload has no well-defined working set and every read is for new data. In that case, you may want to consider using a stored volume rather than a cached volume so that all of your data is already on-prem. If you have a mixed read-write workload, it's important to monitor the cache percent dirty metric, as well as the cache hit rate. Because dirty data in the cache can't be evicted. So until it's been uploaded to AWS, it effectively reduces the size of your read cache. And so every read you make that needs to be pulled from AWS needs to evict something from the cache. That data can't be evicted. So we have to evict something else that maybe was more recently read. So you may get cache thrashing. CloudWatch provides insight into your application workloads, and by using and combining multiple metrics, you can find out what's going on with the gateway and how your application is reading and writing data. Setting alarms lets you proactively monitor what's going on and be able to sort of avert problems. Another great way to monitor Storage Gateway is to use CloudTrail. CloudTrail lets you audit and manage changes to your AWS services. Storage Gateway is already integrated with CloudTrail. So if you have logging enabled today and you've activated Storage Gateway, you'll see Storage Gateway API calls in your CloudTrail logs. This includes all interaction with the service, whether it's performed directly through the API, through the AWS command line interface or SDK, or on the AWS management console. A really interesting use for CloudTrail is to get notification of specific events. So suppose you want to be notified anytime someone creates a new volume, or so that you can ensure that it's tagged correctly for cost allocation, or that there's a suitable snapshot schedule set up so that you have timely backups. You can use Lambda and SNS in a pattern I'm about to show to get an email notification when those events happen. So let's walk through this. So CloudTrail puts logs into your S3 bucket. You can set your bucket notification policy to invoke Lambda. Lambda will in turn invoke a function, which will read your CloudTrail logs, and if it sees one of those create volume API calls, can send an SNS notification. You can obviously subscribe to that SNS notification through email. And the URL on the bottom of the slide is a part of the Lambda documentation. This is this code and more details there on this pattern, but a really good way of using CloudTrail to get notification of specific events. And if you're a more advanced service, your Lambda function, rather than sending out a notification, could solve the problem that you wanted to address. So it could apply tags by calling the tagging API to apply tags to the resource that you wanted, or could call the API to set up the snapshot schedule that you wanted when the volume was created. So hopefully this session's helped you understand Storage Gateway a little better, simplify your adoption of AWS storage services, giving you an insight as to how the service works and how to get the most out of it. If you've not used the service, we have pretty thorough documentation, which includes step-by-step instructions on how to begin. We have an active developer forum where the community posts questions and discuss use cases, and I myself am active on that forum as well. Obviously, we have other developer support options through AWS developer support. But I think the best way to get started on any service is just to try it. Roll your sleeves up and get dirty. And Storage Gateway is part of the AWS free tier, so that helps you get on board. So thanks for listening today, and if you have any questions, I'll take them.